Clara Stegehuis. I will introduce you. You're an assistant professor specialized in probability theory, graph theory, and stochastic networks. That's a mouthful. Please come in. Clara is fascinated by networks. Networks are everywhere around us. Instagram, Facebook, just to mention a couple. But for instance, also the spreading of the coronavirus can be seen as a network. It can be modeled as a network and predicted by means of networks. Also musical networks are very interesting to investigate. That's the topic of this afternoon. Clara focuses on musical networks like linked jazz and explains why some artists and songs are more popular than others. So that's the topic of this afternoon. So we have a big hand for Clara Stegehuis.
Yes, thank you very much. So for the people who have already been at the exhibition, maybe you've seen this before because this is actually part of one of the posters at the exhibition. And this is my own social network. So this is me. And all these other points, those are, in this case, my LinkedIn connections. I think at the poster, it's my Facebook network when I still had Facebook. So a connection means I'm connected by someone to LinkedIn. And of course, some of my friends can know each other on LinkedIn as well. And you can see that these networks can become kind of complex, because if I look at this, I cannot see anything else except that this is me. But then if you try to look for structure in these networks, you can find that you can actually, if you order them in a smarter way, you can find very beautiful structures like this. So networks can be very complex, but if you put in a little bit of effort, you can actually learn a lot of things from them. So for example, now I'm in the center, and you can see that my friends are organized in some sort of groups of friends who know each other very well. But there's only a few connections between the different groups. And the interesting thing is that this is not something that only appears in my particular LinkedIn network. So now let's go to the topic of today. So this is actually a network of jazz musicians. So these were all jazz musicians. I think data was collected from like 1910s to 1940 or something like that. And so these are all musicians from the United States. And a link between means in this case that one musician played in the same band as some other musician at some point in time. So because of course people may change bands, so maybe sometimes you play with this person and then with that other person. And here you can see actually that if you look at this network, then again you have these community structures. So you have these groups of friends that like to play together a lot, and others actually do not play together so often. And a part of this can also, again, be explained if you then start looking at the data. So in this particular data set, so these were all musicians that happened to live in Chicago, and these all lived in New York. So, and of course, you can think that it makes sense that if you live in New York, then it's easier to play with someone in a band who is also from New York than to go all the way to Chicago, especially because there were not so many airplane flights back then. But then you can also see that New York is now also split into two groups. Can anyone guess why there should be two groups of musicians within New York?
Black and white?
Yes. Very good. Yes, because indeed, so remember, so it was the beginning of 1910 to 1940. So back then, I think it was probably not, well, I don't know if it was allowed, but it was definitely not normal for black and white people to play in the same band. So these people are indeed all people of color, and these ones are white people. And you can really see the segregation in this particular network. Of course, so there are still some links, so it wasn't as harsh. But still, if you put it into some detection algorithm, it really can find which players were belonging mostly in the white and which one mostly in the black bands. So this is his network. And the question that you then can ask, suppose that you are like a new young musician and you want to join a band. Like, which person in this network should you ask to join the band? Because of course you want to influence as many other musicians as possible. So who in this network is actually the most important person that you should knock on the door to ask for joining their band. And of course, there are some things that you can do. For example, you can think, well, if you would rather play with someone in a band who has more connections than someone who has fewer connections. This is, of course, the first thing you can think of. And then, of course, you want to go to the one with more connections. Now here, I now made the size of the nodes corresponding to the number of connections. So in that case, it says you should go here, because this person apparently has the largest number of connections. But still, you can think that maybe this is not the most important person to ask. Because like, if you want to also influence people from Chicago, for example, then maybe if you only approach this person, your fame will only be local to New York. So this is why in network science we have all kinds of metrics to define which person is actually the most important in a network. And one of them is the following. So now suppose I want to find the importance of this person. Well, what you can do is you can just compute how long does it take for me to reach all other persons. So for example, these 3 people I can reach within 1 step. And all others actually I can reach within 2 steps. So now I can of course just add all these numbers up if I want to. And in this case, it means that gets 13. So this is just a measure of how close you are to all other people in a network. And then if you repeat it for this one, again, 3 at distance 1. But now there's, for example, there's also some people who are at distance 3. So if you then add these up, then you will see that in this case you get 15. So this person is actually on average farther away from the others in the network than the previous one. So you can of course compute this for every person in the network, and then maybe not so surprisingly, the person in the middle is the closest to everyone. So that has the lowest number, and in this case, so you can see that you can say that this is the most central person or the most important person in the network, even though this person has 3 connections and there are many others who also have 3 connections. And if you now start applying this in this jazz network, then you can see that there's now actually like really one clear winner who is really the closest to everyone else in the network. So before this person he had a large number of connections, but you can see that this person doesn't score so high on being the most important or central person in the network. So this data analysis clearly suggests that if you were in the early 1910s or 20s, you should have approached this person. Now, question is, who is this person? So I don't know how much you know about jazz, but if you know this song, then maybe someone knows.
I see trees of green, red roses too. I've seen it blue for rain.
Yes, Louis Armstrong, great. Even though you probably didn't live in the 1910s. No. Yes, so the person who was Louis Armstrong, and well, I guess so. Probably it may be because of his music, but also if you look him up on Wikipedia, he used to play in both Chicago and New York. So I guess from the network science perspective, that makes him very important because he could go to both these communities. Now, if you like this, so there's also actually a website called Link Jazz that actually does this. So this was just one small data set. They make even bigger, larger network data sets. So you can go to their website and just explore. They have lots of jazz musicians. And in this case, a link doesn't only mean played in a band together, but they also collect data on who knew who were friends, who did not like each other at all. If you like, you can go to this website, and then you can go do very similar data analysis and investigate who is the most important in those networks. I think they are also jazz musicians from a later time period. But anyway, so this is of course only jazz music. Of course, you can also wonder, now, of course, we all did not live in 1910, so it doesn't really help us to know who we should have approached then. So you can also wonder, so suppose that you're a starting musician right now, who should you approach? So what I did is I collected data from the, so this data collection I have to say was 3 years ago, I think, if I remember correctly, for some other lecture. But these are all musicians that had a top 40 song in the year, I think 2019. Don't pin me down. But so these are all musicians that had top hits in 2019. And in this case, a link means that they had that they made a song together. So here I have some examples of people who can appear in this network. So for example, here is Katy Perry. There's Eminem, who at some point had a song with Ed Sheeran. Miley Cyrus, Drake, Beyoncé, who had a lot of songs with Jay-Z, you can see. So most famous artists are in here. And you can also see that there's also some sort of group structures, like in a jazz network, but they're not as strong as before, because of course now we don't have, well, it doesn't really matter where you were born, because you can just take, if you're famous, you can just take a flight anywhere and collaborate with anyone you want. So in this case, so if you look a bit at the communities, I think they're more organized by, these are more the pop songs, these, the purple one, are a bit more rappers. And some, I also don't know why the algorithm thought they were a community. In any case, of course, here you can again see who are the most important people in this network. So again, we want to find out who are the most, who collaborate with the most important other musicians. And in this case, so you can see the sizes. So some are more important than others. So for example, you can already see that Bruno Mars is not going to be the winner. But who is the most important artist in this network? Yeah, someone already says it's Drake. So indeed, so in this one, so I guess you can't really see it by the sizes, because we have a lot of close ties. But if you look, Drake is definitely the winner. Runner-up is Kanye West, then Nicki Minaj, DJ Khaled. And then at 5, I don't know, has anyone heard of this guy, Future? Yeah, so several people had. So I have to admit, before I made this list, I had never heard of this Future. But actually, he is a rapper, and this rapper, he's worked with Taylor Swift, Ed Sheeran, Katy Perry, you name it. Basically, anyone in the pop world, this rapper Future has worked with. So that really explains, so even though maybe by himself he has not had as many hits as Justin Bieber, for example, if you look at the network, this person is actually a better person to get you started in the music world than Justin Bieber, or Katy Perry, or Chris Brown, or, well, basically any other. Now, I don't know, but like in number 6, some other person appeared. This person, I don't know if anyone has seen or heard of this person before. No, okay, so then I also had not heard. So this is a guy named Benny Blanco, and he is actually a producer. So his name appeared on all these, well, he also actually appeared in the artist field in my data set, and he appeared in this analysis as number 6. And so I have never heard of this guy before, but he did work on some pretty famous songs. So.
All the times that you rain in my parade, and all the clothes you get in using my name.
So this person is a producer, and he is maybe not the most famous musician, but it seems from this data analysis that, again, he is one to knock on the door. The network shows that this person is really a good person to have in your friends list. And this brings us to another mathematical topic, which is the power law. And you can see, well, it's a bit unfortunate that you can't really read the numbers because they're on the line. But here you can see the number. So if you look at any given year, and you look at the top 10 producers. So you can imagine there are like millions of producers around the world, but you just take the 10 producers who produce the most hits in 5 years. Then you can see that in 1985 to 1989, only they made 19% of all top 100 songs. So that's actually already quite big. So 10 producers make 20% of all top songs. In this case, it was mostly by George Michael. But you can see that this number is basically increasing and increasing and increasing. And up until 2010, where only 10 producers made 43% of all top songs. So this is really unbalanced. So you can say that 99% of producers probably don't make one single top hit. But then there's like a very few who make 43%, or in 2015 to 2017, 32%. The same Max Martin. And this is a phenomenon that you see in many other places as well. That only a very small fraction of a population accounts for a very large amount. So one other thing is where you see this, for example, on Spotify. So if you see the number of plays per artist, so here's the fraction of artists, and this is how many plays they have. So this was only a small sample of Spotify. But what you usually see is that if you have the number of plays, so further to the right is more plays, and further down means more unlikely. So in this case, that means that almost all artists have a relatively low amount of plays on Spotify. But there will always be some artists who have a huge amount of plays on Spotify. And again, of course, this is a very small data set, because of course here's 10 to the power 4. Of course, there are artists that have probably billions of plays on Spotify. But you can actually see this straight line on a log-log scale. So again, for example, here there's the word frequency in books. So if you count how often does a word appear in many books, and then again on the right you can see how often you count a specific word. And if you go to the top, that is how likely it is. So basically it means that most words only appear 10 to the 0, so 1 or 2 or 3 times. But there will always be a few words like the or and that appear even 10 to the power 4 times. Same holds for scientific papers, for the ones here who write them. Most papers will actually not receive so many citations, but there will always be a few that have many. You can say the same for web pages on the internet, magnitude of earthquakes, or number of books sold. So again, most books are not sold so often, but there will be books like Harry Potter or calculus that are sold maybe 10 to the power 7 times. And this is very different from the usual normal distribution. If you look at the normal distribution, for example, if artistic performance would have a normal distribution, that would mean that almost everyone is average, so everyone has like average number of plays or hits, and some are a bit better than average, and some are a bit lower. But for this power law, it's actually not true. So here it says the power law actually said like almost everyone is just rubbish. They are low performance. But there are very few people who they call them hyper performance, who are like, well, the Justin Biebers or Taylor Swifts. So that is very different from this normal distribution, where maybe here we have the average, maybe some people have like 2 times the average number of plays. In this power law, you can have 20,000 times the average number, and it's not even that unlikely. Whereas in a normal distribution, that would be extremely unlikely. And for the people who know a bit of economics, in economics, this is actually known as a Pareto principle, where they say that 20% of the population owns 80% of all wealth. And there you can again see this curve, where the number of people here is here, and here is the wealth. So yeah, this appears in many different places. And mathematically, you can actually write it in the following form. So suppose that I want to know what is the probability that my book gets sold or that my hit gets streamed X times. Then you can write it in this power law as x to the power minus alpha, where alpha is some parameter, and that depends a bit on how strong this power law is. So this alpha is larger than 0. So then that means that the larger x, the smaller the probability. So the probability that I will have only 2 streams will be relatively high. But the probability that I will have 1 million streams will be 1 million to the power minus something, which will be very low. And the value of this alpha, you can actually estimate it by sort of looking how steep this slope is. So the more flat this slope, the lower the value of this alpha. So this tells you something, for example, is it true that 20% of people has 80% of the wealth, or is it even stronger? 20% of the people have 99% of the wealth. And this equation, so like this universal, so all these plots here mean that you can not only apply this equation to Spotify data, but you can also, for example, apply it to the probability that a book gets bought X times, or the probability that your website gets X visitors. So to go viral, you really have a very low probability to go viral. But what can you do if you think that maybe your probability of going viral is on the low side? Well, of course you can use your network. And that is exactly what this guy did. So this is an astronaut. And at some point, I think he made the first music video in outer space. And it was this particular video. Yeah, so this guy probably cannot even sing in outer space, but he still made a music video. And the nice thing is that you can actually collect data on Twitter and see how fast this video went viral. So it was posted at 12th of May 2013 at 2022. Commander Hadfield, that's his name. And you can see how it went viral. So you can basically see that, like, in the first 2 hours, he has basically, well, reached almost, many people. And of course, it will still, more people are appearing. So in this case, a link means that this and one other person retweeted the tweet of that other person. So the first tweet was by this guy, Hadfield. But then, of course, some other people, so the blue ones, they also start retweeting. And then it goes into retweets of retweets of retweets. And you can see how this goes viral. So I think so even if you think that you don't have a high probability of going viral, it's always good to go to a super spreader like this Commander Hadfield, who is probably one of the persons who knock on the door. Even though he's not in the music industry, important people in the network can really help you to go viral. Thank you.
Clara, thank you very much for your really nice talk with beautiful music and fascinating mathematics behind it. Then I want a big hand for Clara Stegehuis.